Hello, my lovely humans. So today this afternoon, we're going to look at a question 8 on the 2024 paper around um, shortest, best path stuff, optimal path. Um, and from the diagram here, we have so much going on, and there's arrows everywhere. So we can see that it's a weighted graph because the arrows are showing which direction we're going to go. Or sorry, not weighted, directed graph. Um, which is fine. So what's going on? So a company director, this is question 8 2024. A company director wishes to design a business plan to promote her brand over 4 years. Each year she chooses a different number of different promotion strategies. She estimates profit or loss for each strategy. Why you'd use a negative strategy, I don't know. Anyway, I suppose invest and make profit later. She draws a network shown below to help design the most profitable plan, where the edges are different strategies and the nodes represent possible states. So the nodes are kind of where we are in our 4-year plan, with X being the starting point and Y being the finishing point. And I guess the idea is going to be that we are going to find the most profitable route from X to Y, depending on what the plans are. Now, immediately we see those dotted lines there, there's 5 of them. That means that we've got 4 stages. And when we see a graph like this, we got 4, 3, 2, and 1. We are going to be using Bellman's principle of optimality, or dynamic programming. So the principle of optimality is that the shortest path in any one stage or any one section is contained within the shortest overall path, or the shortest overall path contains every shortest sub path or sub route. So the idea is we're going to find the shortest path in stage 4, and then do that for 3, and then do that for 2 if the dog showed up, and then do that for 1. And gradually we are going to create the shortest path. So what we're going to use is the strategy of dynamic programming. It's a fancy name for just, we're going to start this at the end at 4 and see what are the optimal paths in stage 4. And what that is the optimal path going from each node at the start of stage 4 to each node at the end of stage 4. So the first one is kind of going to be trivial because we're going to get 3 optimal paths because we have only 3 options. We have GY, HY, and IY. So we've got 3 separate paths, and they're 3 optimal paths. I think the cat is torturing the dogs, but we'll just have to put up with it. So we've got G, H, and I. The first thing, so we're going to have 3 optimal paths there of certain weights, I reckon, and we'll have a look at those in a second. Then we go into stage 3, and then what we're going to do is we're going to examine from D. So we're starting on D, so we have 3 options, DG, DH, and DI. So what happens there is we're going to add up the cost or weight of DG to GY and get a value. Then we're going to add up DH to HY and we're going to get a value. And then we're going to get DI and IY and get a value. And depending on what we want to maximize profit. So we want the biggest number. Whichever one of those is the biggest number, we keep. And that's the only path that goes from D to Y that we need to worry about from here on in, because it's the shortest path, it's the optimal path or the biggest value, or the optimal bit in stage 3 and in stage 4. So what's going to happen, we're going to do that for D. We're going to find out which one of those 3 is the optimal one to go from D to Y. Then which one is the optimal one to go from E to Y. And then finally, which one is the optimal one to go from F to y. So by the end of it, we'll have at least 3 optimal paths. It's possible that there could be more than one from E or from F, which are optimal. But then we have those optimal paths, and then we go into stage 2, and we do the same thing over and over again. And we get new optimal paths, and then finally we do the stage 1, and we get our optimal path overall, or more than one if they have the same value. So that's the idea. We start at the end, and we're going to gradually work backwards to get the answer. So these are the estimated profits. We have basically these are the weights of each of the edges on the graph we have. You notice one other important reason about doing dynamic programming and using Bellman's principle is that we can use negative weights. With Dijkstra, we can't. So what we have to do, if we see something with negative weights, it has to be dynamic programming. So what we're going to see is stage 4 is going to be our G. Oh, for God's sake, one note. Stage 4 is going to be G, H, and I. Then stage 3 is going to be these guys, D, E, and F. Then stage 2 is going to be A, B, and C, and then stage 1 is that. So maybe it'd be useful for you to write on the paper. 1 is those guys. 2 is those guys. Thankfully the dogs are shut up for now. 3 is those guys, and stage 4 is those. So 4 is going to be fairly trivial. 3 and 2 are going to be more involved and annoying, and then 1 is going to be quite quick and get us the answer. So how do we do this? So actually we haven't even read the question yet. But it's one of those things where you probably don't. You can just know what it is you're going to do before you've read the question, but let's read it just in case. Use Bellman's principle of optimality to calculate the business plan that maximizes profit. Relevant supporting work must be shown. So the principle of optimality is that the shortest route or the best route from X to Y always contains the best route between any of the other areas. So from A to Y, the best route from X to Y has to contain the best route from A to Y, or B to Y or C to Y, whatever it is between stages. So we will see. So stage 4, first of all. So stage 4 is what we're going to do first. Now, relevant supporting work must be shown. This one's okay, it's easy enough to write it out. It feels a bit like busy work, but it is easy to write out what's happening. With other ones like with Dijkstra or Prima Kruskal, it's harder, but we figure out that as we go. So stage 4, what are the options for stage 4? Well, we have GY, HY, and IY are the 3 paths in stage 4. So what I'm going to do is actually I might write this down. So GY, HY, and IY. So they are the 3 paths in stage 4, and they have certain weights, and the weights are all over here. GY is 6, HY is 5, and IY is 7. Okay, cool. So that's easy enough if you can remember. So it's 6, 5, and 7. Cool. So what we need to look at now is from each node at the start, each node at the end, which ones are optimal. And because we have 3 different starts, they are all considered optimal. So we're going to have to deal with all 3 of those because they're all coming from different places. So we have to think of those as the optimal routes between nodes at the start of stage 4 and the end of stage 4. So that's stage 4 done. So that's 1/3 of it done. So then Stage 3 now, I'm going to get into stage 3. And what are the options here? So with stage 3, here's where it gets tedious to write. We have DG, DH, and DI. We have EG, EH, and EI. And we have FG, FH, and FI. So what we have to do now is, sorry, we start with D. And where can D go in our graph? D can go from G to G to H to I. So the options for the path are DGY, because the GYs are optimal from G, DHY, and DIY. So they are the paths from G to Y in stage 3, but we also have, because we have E and F as well, so we have E, GY, FGY, and no, not EG, sorry, I'm getting ahead of myself. EHY and EIY. I've just chosen this way to do it, to start from the start nodes and finish in the end nodes, rather than work on the middle ones, but whatever way works for you. FGY, FHY, and FIY. Now let's just make sure. So we've got 1, 2, 3, 4, 5, 9 different paths in stage 3. Stage 3, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 paths. So we need to look at DG, DH, DI, EG, EH, DI. So we need to go here. And let's look at the D ones in stage 3, which we've kind of put a bracket around there. DG, DH, DI. So we'll just write these ones out and then we'll figure out what to do with them. So -5, -3, and 3. Again, I'm just flying through the scrolling up and down, so you can pause it as you need to and then go back, and hopefully what I'll say will have made sense. So GHI is -5, -3, 3. Okay. -5, -3, 3. So we've got -5, -3, and we have 3. So just confirm that that's right. -5, -3, 3. Yeah, cool. So that's the cost to go from D to G, D to H, D to I in stage 3. But we want to see what the best route is. It has to include what we know about stage 4. So we know that GY is 6, so because 6 is the optimal route. So that gives us -5 plus 6 equals 1. One note is very nice sometimes. So that's the total profit of 1 between stages 3 and 4 from D. Then we got -3 plus 5 is 2. And then we have 3 plus 7, which is 10. So going from D, our optimal route is DIY. So that's the one we're going to carry on to stage 2 from D. I hope that makes sense. So what we've looked at here is we've looked at if D is part of our optimal path, what's the optimal way to get from D to Y? So it's either this one, or this one. And what we've worked out by adding the values of those edges, it's DIY. So we know DIY is the optimal route from D to Y if D is part of the overall optimal path. And we now know that DGY and DHY are not optimal, so if we end up at D, we don't go to G and we don't go to H. Now, why is that decided not to undo on me? And there we go. Grand. Okay. So what we're going to look at now is we're going to look at the same thing from E. So EG. And I'm just going to mark these off as I go through them just to make sure I don't forget any. So we've done those three. We've done those three. Then I've got three more. -2, 5, and 6 from E. So -2, 5, and 6. Again, if you have the paper in front of you, this is much easier for you to follow along with. -2, 5, and 6. And because it's EGY, it's -2 plus 6, because 6 is the optimal path that includes G. That gives us 4. Then it's plus 5, because 5 is the length of the optimal path that includes H. And that's 10. I'm just going to format that. And then -6 plus 7 equals 13. So the optimal path that includes E is that EIY. And I'm just going to put a little line through the ones that are not optimal, just so I remember not to worry about them. So we have two optimal paths, or possible optimal paths so far, and we're going to do the same thing for F. And looking at F is 4, 3, 2. So it's F to G is 4, F to H is 3, and F to I is 2. So that is 4, 3, 2. And again, because GY optimal path is 6, HY optimal path is 5, and IY optimal path is 7. And what we have there is FGY is our optimal path, and the other two are not. Okay, so that's what we have now. Is we have three possible routes: DIY, EIY, and FGY. So let's see what happens when we look at stage 2. Now I'm going to have to do a bit of annoying one. So I'm going to put that over here, start typing up here. So this is, I'm just going to put it up here so we can kind of look at the whole thing. So up here is, what are the nodes? I think it's A, B, and C. So the start nodes are A, B, and C. And what we do again is we start with A, go to all the options from A and write them out. Then we all the options from B, write them out, and then all the options from C and write them out. So here I think is where the thing starts to pay off. Let's sneeze just 1 second. Oh, okay, great. So where are we? Stage 2, or sneeze break in effect. Stage 2 then becomes, it is nodes A, B, and C are the starting nodes in stage 2. So it's A to D, A to D. Now where does, now here's where it begins to make sense. What is the optimal path from D? And the optimal path from D is DIY. So the optimal path from D is here. So if you find yourself at D, you finish up with DIY. Then A goes to E and then to F. So A goes to E and then A goes to F. So if we find ourselves at E, it's EIY, and if we find ourselves at F, it's FGY, because these are the optimal paths here and here. So what we now look at is what's the weight of the path from A to D. A to D is 5, so 5 minus 2 minus 5. So it's 5 minus 2 and minus 5. Just want to make sure that's correct. Yep. So this is where we're at. We're at 5 minus 2 and minus 5. So we now need to add in the cost or the weight or whatever we want, however we want to think of it, of the path DIY, which is 10, which gives us a total of 15. Then it's AEY, which is 13, which gives us a cost of 11, and then FGY gives us a cost of 10, which means we have 5. And what that tells us is, I just want to make sure my calculations are correct here. Yeah, we have ADIY is our optimal path, and the other two are not optimal. So we'll just put a line through those just so I don't forget about them. Has the thing crashed? No, it hasn't. Okay, that's one thing. Cool, so that's that. Then we need to go from B, and it's B DIY, B EIY, and B FGY. And the weight of B to D is 7 minus 3 and 4. 7 minus 3 and 4. Again, you have the paper there, so hopefully 7 minus 3 and 4. So we now see what is the weight of the path DIY. So B to D is 7, then DIY is 10. B EIY is 13, and BFG is 10. So again, we have the optimal path seems to be including DIY all the time, which is cool, interesting. Bet you to be stinging the tail. But those two are not optimal, so we can ignore them. And then finally we have C DIY. Sorry, I'll do that. C DIY, C EIY, and C FGY. So what is CDI? So what do we need to figure out? CD, or let's figure out, read. CD is 5, CE is minus 4, and CF is minus 1. Okay. So 5 minus 4 minus 1. So it's 5 minus 4 minus 1. And again, we put in the weights for our DIY. The weight for our EIY, which is 13, and the weight for FGY, which is 10, which is 9. So what that means is our optimal paths so far all include DIY, which I guess is not a surprise, but not a surprise in reality, but I'm surprised that we don't have some options as part of the question. I thought they'd written it a slightly different way. Anyway, I'll just move that up so we can look at stage 1 then. And stage 1 is where the answers are going to arrive. So with stage 1, we have from the source point X to A, B, and C. And we're going to get 3 options, so it's a lot less writing. So that is XA, XB, and XC are the 3 routes in stage 1. So if we're at A, it goes DIY, so it's A DIY. If we're at B, it goes DIY. And if we're at C, it goes DIY again. Again, I'm surprised that the question has resulted in 3 very similar solutions, but I guess it is what it is. So now, what are the profit loss for in stage 1 is minus 11, minus 13, and minus 9. Okay, so minus 11, minus 13, and minus 9. Grand. And then we look at what are the optimal paths for each thing. So it's plus 15 for DIY. A DIY is plus 17 for B DIY. 2 the same, so 2 optimal paths, excellent. Plus 15 for C DIY. So actually we have 1 optimal path. After all that is a profit of 6. I think it's in thousands. So this is the kind of relevant work shown, just working through each stage. And the question was calculate a business plan that maximizes profit. So it was X, C, D, I, Y, and it was 6,000 in profit. And I'll stop there. Again, pause it, go back, work through the question yourself, and as soon as you get stuck, find this. I'm going to quickly look through the marking scheme and just to see what we're at here. So this whole thing I've just done was worth 30 marks. So 0, 8, 16, 24, 27. So if you got 1 stage right, you're on 8. So I'd say, I imagine we're on 8. If you get that right, this, you're on 16. If you get that right, this, if you get this right, so if you're getting it all right, this, if you get this right, is 27, and then the last 3 is getting this. So there's 1, 2, 3, 4 stages plus the answer. So if you get any 1 stage, you get 8, any 2, you get 16, any 3, you get 24, any 4, you get 27, and then the answer is that extra 3. So again, process above all else. And they do, even just starting, it gets you 8 out of 30. So then if you can get something in the next bit, you get 16 out of 30, and that's 50%, and your head's above water before you've done any of the thinking. So cool. If there's anything I can explain in the comments or with a new video, just let me know. Good luck.